everyone. Let us today talk about standardization in data science. So, standardization in data science refers to the process of transforming data to ensure that it has a standard format or range. This is often crucial for effective data analysis and modeling. And this involves adjusting the data features and their values so that all the features have similar scales, distributions, or representations that will help algorithm interpret and compare data more accurately. Standardization becomes important to improve the model performance. Many machine learning algorithms, like gradient descent based models, rely on the scale of data to converge faster and find optimal solutions. And algorithms like support vector machines and principal component analysis are sensitive to the magnitude of features. It is also important, standardization is also important to avoid bias because features with larger ranges can disproportionately influence models if the data is not standardized. Standardization also ensures consistency and ensures that the data from different sources or units can be meaningfully compared and used in our models. Let us learn about different methods of standardization. There are different methods present in sklearn library, scikit-learn library, pre-processing module. So the three common methods of standardization are standard scaling, which is also called as Z-score normalization. Here, the Z-scores of the values are used to replace the values in a feature. So since Z-scores are used to standardize the data, this technique is called standard scaling. So it adjusts the values by replacing the Z-score so that the final distribution of the data will have a mean of 0 and standard deviation of 1. So this uses the mean and standard deviation of the data. So this can be applied to those data sets with normal or near to normal distribution. Next method of standardizing is the min-max normalization, where we depend on the minimum value and the maximum value of the data. So typically the range of the data to standardize the data. So this method scales the values of data between 0 and 1. In standard scaling, you might come across negative values, but min-max normalization, irrespective of the original values of the feature, will always scale the values to between 0 and 1. So min-max scaling is used when your algorithms are sensitive to the magnitude as well as the sign of your data. Robust scaling, on the other hand, the third method of standardization available, uses your median and interquartile range. Since when your data has outliers, your median and interquartile range are very robust and not affected by the outliers presence. So hence, the scaling method is called robust scaling. This is used only when data has a lot of outliers. So apart from standardization techniques, transforming data is also a way of standardization. For example, logarithmic transformation, where data has exponential distribution or large skewedness, can be transformed into a near to normal distribution by applying logarithmic function to compress the range of values. So these are also indirectly you are standardizing the data. Now, let us learn some trivia facts about standardization. Now, when do we standardize? We standardize especially when we are using distance-based algorithms, KNN, K-means, all of them. Now, also, those algorithms which are sensitive to feature scaling, support vector machine, PCA, and your logistic regression. So in those cases, standardizing becomes importantly inseparable part of your pre-processing. Tree-based algorithms do not need standardization, but standardizing is always a good practice to understand and compare different features. Now, impact of outliers significantly affects our standardizing. For example, if you standard scale a data or using the z-scores or your min-max normalization, the maximum value of the data or the standard deviation of the data highly affects the value of the transformed feature. Similarly, standardized data might lose its original interpretability. So transformation should be reversed in case you are presenting results or your insights. So we should also remember to use the same parameters of mean and standard deviation derived from the training set for standardizing the testing data set. Also, choosing the right method depending on the data distribution as well as the algorithms used will be really important to achieve the real effect of standardization. This is the end of a beginner's guide to standardization in data science. Let us meet in our next video.